Now, there are so many number of problems based on this conservation of angular momentum, and we discuss those problems also. Now after that, so now we are coming to the what is the energy of a rolling body. Energy of a rolling body. Suppose now here the body is there and the force is applied on it and the body gets a translatory motion, then it will have the energy, that is the Ke is equal to half mv square. Suppose if at all a body is rotating here only, that is just like a fan. So if at all it is rotated there only, it is purely having that rotatory motion. So in that case it will have the KER, it is the KET, translational kinetic energy, and KER, rotational kinetic energy, and that will be taken as the 1 by 2 I omega square, because as you already know, in place of the m in angular motions I should come, and in place of the v, that is the linear velocity, here it is the angular velocity omega square, so 1 by 2 I omega square. But in this case, that is in case of that rolling body, it has both the translatory and again it has both the translatory and after that rotatory motion. So both the translatory, that is the progressive motion is there. So translatory motion is a progressive motion and rotatory motion is a non-progressive motion. Here also it has a progressive motion and with respect to that axis it has the non-progressive also. Suppose now here in this case it is the Ke is equal to Ket plus Ker. Ke is equal to Ket plus Ker. So that's why it is the 1 by 2 mv square and thereafter 1 by 2 I omega square, and here it is the 1 by 2 mv square is there, and 1 by 2 I omega square means I is the mk square, omega square is the v square by r square. When you are taking that half mv square is the common, that becomes half mv square is equal to of 1 plus k square by r square is here, 1 plus k square by r square. Already you know k is the radius of gyration. So that's why this is the Ke of the rolling body, which has both the translatory and the rotatory motion. So it is the Ke is equal to half mv square of 1 plus k square by r square. And here k square by r square, that you have to find it separately for the rolling body. Rolling body means all those bodies do not come under, cannot be taken as the, all that rigid bodies cannot be taken as the rolling bodies, cannot be considered as the rolling bodies. Here suppose a solid cylinder is there and the hollow cylinder is there, and again the next circular disc, and after that circular ring, and again the solid sphere, hollow sphere. So these are considered to be the rolling bodies. Now here how to find out the k square by r square for them? And don't by heart that k square by r square for any rolling body. It is better to find out that k square by r square there only by taking that general formula. The general formula is the mk square is here. Suppose if you want to find out the k square by r square in case of the solid sphere. So now solid sphere about its natural axis. So natural axis means in case of the solid sphere, its natural axis is nothing but the diametrical axis. So that's why it is 2 by 5 mr square. So 2 by 5 mr square. Now k square by r square is equal to 2 by 5. That becomes k square by r square is equal to 2 by 5. Suppose in case of that hollow sphere, it becomes the 2 by 3 mr square. So that's why it is a k square by r square is equal to 2 by 3. And its meaning is that a general formula should be compared to that of the general formula should be compared to that of the natural axis of that particular rolling body. Then only you can find out that k square by r square. Suppose in case of that circular ring, then in that case it is the mk square is equal to mr square to be taken, because in case of the circular ring, a diametrical axis cannot become the natural axis. That axis passing through the center and perpendicular to the plane of the ring, that becomes the natural axis. So that's why mk square is equal to mr square, and it is the k square by r square is equal to 1. So like that you have to get that k square by r square there only. You don't by heart all these values for the different rolling bodies. So you have to obtain that k square by r square immediately within seconds. Now we are coming to this, that is the energy of this rolling body is over half mv square of that 1 plus k square by r square, and thereafter we are coming to the next concept, next point. So far in this second phase, what we have discussed this, so there is the angular momentum, And again, the second phase of rotatory motion, we have discussed the angular momentum and the conservation of angular momentum, and thereafter applications of angular momentum, conservation of angular momentum. Thereafter, it is the kinetic energy of that rolling body. Now we are coming to that velocity and the time acceleration of that rolling body along that inclined plane. Velocity, time and acceleration. Suppose here we have taken some rolling bodies here, and now first of all we are coming to this velocity. Velocity of this body we discuss in three cases. So first of all, if at all it is dropped here like this, if at all it is dropped from this height, and this is the L is the length of the inclined plane, if at all it is dropped from here, then what is the velocity that it obtains while it is reaching the bottom of this plane? So on this ground level, in that case, what is that? Next one is what is the velocity that it obtains? What is the velocity that it obtains while it is sliding on this inclined surface? Sliding means then there is no any friction at all, so that's why there is a sliding is here. And the next one is what is the velocity of this rolling body when it is reaching the bottom of this inclined plane. In all these cases, that is the vertical displacement that it covers is only the small h only. In all these cases, for the freely falling body and the sliding body and after that rolling body, in all these three cases, the vertical displacement through which it is falling is the small h only. You have to find out the velocity in all these three cases. So first of all, for the freely falling body, in that case, it is taken v square minus u square is equal to 2as, and v square minus 0 and 2g, s is the h. S is the h. For the freely falling body, the vertical displacement covered is the, it is the h is there, and v is equal to square root of 2gh. V is equal to square root of 2gh is there, and for the freely falling body. Next again, when the sliding body is taken, and for that one, it is the v square minus u square is equal to 2as is the formula. And thereafter, for the sliding body, what is the force that makes the body to slide? That is the mg sin theta. Acceleration is the g sin theta. So that's why it is the v square is e minus 0 and 2g sin theta. And in place of the s means this is nothing but the s, and here you have to take sin theta is equal to sin theta, that is taken as the h by s. So that's why s can be replaced by h by sin theta. So it is the h by sin theta that can be replaced. So ultimately it becomes the square root of 2gh only. V is equal to square root of 2gh only. This is for the freely falling body, and this is for the sliding body, and ultimately our target is to get that velocity gained by that, that is the rolling body. So in that rolling body, here you have to get that velocity by applying the conservation of energy. That is loss of potential energy is equal to gain of that energy. So according to that, for the rolling body we are taking, in this case, it is the loss of PE. According to conservation of energy, loss of PE is the loss of KE of that rolling body at the bottom of the inclined plane. So loss of PE means it is the mgh, and loss of KE means already just now we got it, it is the 1 by 2 mv square of 1 plus k square by r square is here. 1 by 2 mv square of 1 plus k square by r square is here. And in this case, that is the m will be cancelled, everything is there, that is v is equal to square root of 2gh by 1 plus k square by r square. This is for the velocity of that rolling body at the bottom of that inclined plane. Now we can compare all these velocities. So here it is the Vf is there, root 2gh, and Vs is there, root 2gh. From that, what you can understand, that is a body which is allowed to fall down freely from certain height is equal to the velocity of that sliding body that is on this frictionless surface. Frictionless surface only. If at all it is a frictional surface, then definitely this value will be less when compared to this one. but it is a frictionless surface. So that's why it is the Vs is equal to root of 2gh only, and Vr is definitely will be less when compared to these values. So that's why we can give this order Vf is equal to Vs, and that will be greater than that of the Vr, that is the rolling body. This is the relation from among them. It is the freely falling body, and again this is sliding body, and again this is rolling body. And thereafter in my next class I will explain that is the time acceleration of this freely falling body and the rolling body and the sliding body at the bottom of the inclined plane. Similarly, for that is the time taken also for all these bodies. So time taken, and after that only we can come to the problems based on this. So we will continue in the next class. Thank you.